Hey, it's me, Shrop. So, got kind of a different idea for our video today. Not sure if I'm going to make this one long video or a few videos or exactly what, but these are pieces of steel. These are raw material, 2-inch square section, just a little bit less than a 1/8 inch wall thickness. It's pretty thin. And I'm going to build a desk. Out of this butcher block here, which is currently my coffee table. So why am I doing that? Well, it's because this is my current desk. Now, you may notice if you were alive in the 1980s, you might recognize this as a kitchen table, which is what it is. So it's actually a really great size. It's the perfect length. The trouble is, it's a kitchen table, so underneath it, there's not space for your knees. I mean, my knees fit under there, but it would be great to have an empty space there. So I guess the thing here is design process. Now, as you can see from my drawing, this is pretty simple. It's a rectangle. One of the things I personally like when I'm fabricating is I like for the entire inside of the steel to be connected. In other words, I don't like chambers. I like if you blow in one end of the pipe, the air should come out the other. So in order to do that, you need to miter cut your corners. But what I want to do here is a little more sophisticated. So I got thin section steel, and you have to make choices, right? When you're designing something, even something as simple as a rectangle. So why thin steel? One, I don't want the thing to weigh 400 pounds. It's already going to be way stronger than a piece of IKEA furniture or something like that would be, because it's made out of such a large cross section. But two, I want to fold the ends. So you see this part of the drawing here. If each one of those blocks is 1 inch, forget the wider one, the 3-inch one. This is 2-inch tube. That means if I leave the tube 1 inch longer than I need it to be, and I shave 45 degrees, then I can hammer the corners in and fold them down like kind of wrapping a Christmas present. And they'll meet and make a nice, neat, tidy box end. And then I won't have to cut a plate to weld on the end. I'll just have an X weld across the end. And then I can buff that out and it'll look like it's just one solid lump of metal. I've never done that. And I've also never done a double miter end. So the regular miter box cut joint that you saw on the 1-inch pipe that I made the coffee table out of is just cut the way it looks, 45 degrees on one axis. But if you cut 45 degrees on 2 axes, then you can join 3 pieces together and you can make a corner. So these corners here on the drawing, that corner is the back here. There'll be a vertical piece here, a horizontal piece, and then this square is the piece that's coming up out of the paper. And all 3 of those will join, and there will be a hollow joint here at the corner. So from the side, this is the side view, it'll look the same as this does. But if you looked at it, I guess, from the inside corner, from down in here, you would see another seam. And so that means this entire structure as drawn in this rectangle will all be contiguous. If there was a mouse or something, it could go in any one of these tubes and come out through any of the other holes. And then I'll cap all 4 with that like Christmas present folded deal. So that does add some unnecessary complexity, but it's a growth exercise for me as a welder to kind of, increase my skill set. And because this stuff is so thin, like I don't want to support it. I don't want to add any extra structure. I like my stuff to be open and minimalist like that. See how you kind of don't see the steel frame and it kind of looks like the table is floating? That's the desired effect here. I'm using thicker steel this time, and I'm going to run it out to the edges because I want to maximize space for my body and for the PC and whatnot underneath. Okay, so one more thing. So how do you make accurate cuts? Obviously, you need to be accurate if you're going to try to put together like 3 pieces in one corner. This should allow me pretty good accuracy. Here I can dial this into 45 degrees and feed material into this bandsaw, which is a porta band on a stand. This is from Swag. These things are really great, these stands. They're not terribly expensive and they're pretty effective. And with this, they become reasonably accurate, and you can tune them, and you can still disconnect the bandsaw and use it in your hand. And then I also have this, which is a Win. I got it off of Amazon. This is great for stock up to 3 inches straight. I cannot do a 45-degree angle cut on a 3-inch piece on this because when you turn the saw, the body of the saw interferes with, it hits the stock, hits the workpiece. But 2 inches, I can cut it 45 degrees. So those are the kinds of things that impact your decision making. Like, my initial instinct was to build this in 3-inch steel, but I can't cut 3-inch steel as easily with the tools I have. So these 2 saws are more accurate than me cutting it by hand, like with a die grinder or a cutoff wheel. So accuracy in cutting and measuring leads to better fitment, better fit up, leads to easier welds, and it's more likely that my final product will be true and square, and I'll be happy with it. It gets to be one of those things where your skill set is good enough that other people might be satisfied with your work, but you've got to live with it. You've got to know that you made this thing and put it out there into the world, and that it is either good or it sucks. And whether or not it works, whether or not it's good, is something that you own. And so I'm going to sit here under this table and look at it every day that I go to work. So I want to know that it's right and that it's as good as I'm capable of making it right now. So that's what I'm going to do. I'm going to try some new angles and some new joins and do some TIG welding, and I'll update you and we'll see how it goes. This block is just over 2 inches thick, and the steel I got is 2 inches. So my hope is that it kind of looks right together, and I'm probably actually going to even paint it this time. Crazy talk, right? So I will paint, well, I will build it first and see if I feel like painting it. But the proportion of the side of the block and the steel frame should work well together. Okay, so I have used my grinder and gotten the mill scale and filth off of the ends of my stock here. Taking a break now because it's about 740 degrees Kelvin outside, but I've gotten all the ends cleaned up, and next up I will remeasure all the pieces and then mark out my cuts on the ends here. So there'll be some 45-degree lines and some squiggly areas that will cut away. And then once the cutting is done and the measurements are confirmed, I can start tack welding stuff together. Okay, so I figured out I can't make the cuts for the Christmas present folding end with the bandsaw. I've got to do it with a cutoff wheel because I can't cut through the sides. So this is the desired measurement. Really, it's what I need is the diagonal lines. I'm just using the vertical line here as a locating point. And I checked this by measurement. It didn't occur to me just intuitively. I guess, you know, for people that do carpentry, it would probably be obvious, but this stock is 2 inches wide, and that line here that etch mark is in the center of my stock. So if I put the triangle on, that keeps it level or parallel to the workpiece. And I slide it up until you see just barely the tip of the line is in there. See it? And I scribe back here, there, right? And if you verify that, this should be 1 inch down because that's what 45 degrees means, right? So that works. So you do that on each side, and then I just cut the diagonals, and then I can fold the tabs in, and that should work out just fine. Okay, what's going on here? This does not spark joy. So I was gonna try to make this thing like kind of come together like a Christmas present. Definitely a learning experience. I'm gonna leave it in the video. I should have scored it here, where that line is. I should have scored that there, and I didn't. And as a result, that bend here is kind of rounded. It's not precise, it's not broken. And therefore, even though I did I think a very good job of making these cuts clean, the bend sucks. And so the package end didn't meet well together, and it's bunched up, and I need to straighten it and then re-edge it and then unmess it up and fix it. So I could do all of that, and I just don't want to. And I considered doing it for the sake of the video as a learning experience or to demonstrate it, but I really, really don't want to, because what it means is that even if I had etched that correctly, that's an additional step. So in order to make this even incorrectly, I had to do some measurements, I had to do a lot of head scratching, some fairly high accuracy cutting with a cutoff wheel. And I greatly prefer to use band saws and things like that where accuracy and repeatability are greater. So this requires skill, and it requires a large amount of time investment, a lot of precision measuring, accurate etching, and then cutting, and then you can't use the most efficient tools with this stuff. I don't have a huge compressor, so there's a certain amount of waiting time for the saw to get enough air to run, blah, 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 blah. It just kind of ultimately sucks. So I'm not gonna do it. And I'm gonna be man enough to leave it in the video so you can see that I messed up. The experienced among you might have predicted that when you saw that I didn't etch that line. I thought I could get by bending it. I was wrong. So I've learned that. Won't make that mistake again. I also won't design in that way in the future. So it's definitely a valuable learning lesson, but it's not something I'm going to continue. I'm going to not do that. So I'm going to cut these off. But the part that I'm really interested in is the actual double miter cut. So I'm going to cut all of these to 30 inches to get rid of the little learning experience that I've had down here. And so once they're all equal length, I will then cut, or I might just take it, heaven forbid, take off 31 inches. I mean, do the cut with them at regular length. Got to decide if I'm comfortable doing that. So I guess that's kind of the point here, right? Is the learning. So I'm trying to learn to be efficient. I know that I can accomplish the task. There's no doubt that I can cut these and make them fit together. What I'm trying to do is get better at that. So I don't need to cut them all to 30 inches short and then take the angle. I should be able to take the angle and the length at the same time. And I'm not sure which is quicker. Also, this saw has an attachment that I can hook in, screws in here, that is, it's like a butt stop that will hold my work pieces at a specific length, but it doesn't go on the back. It only plugs in the front, and it's not long enough to allow me to cut these off in a repeatable manner. So I have to actually position the work in the saw 4 times and get it right 4 times. If I'm doing the double miter, that's 2 cuts per part, and if I cut them all off to length, that's an additional 4, so that's 12 cuts, right? So a pro would probably only make 8 of those cuts. So I'm gonna see if I can figure out, I'm gonna make my adjustment, move down an inch, and see if I can do it that way. And if not, I can go back to the steel yard and make another video about mistakes. We'll see what happens. That's it. I'm buying camera holders. Gimbal, stand today. So anyway, mount to it from the side just like before, and you can mount to it from above. So okay, so I'm pretty pleased with my cuts. And this is just sitting here. Look at this. I think I'm going to reshoot that in better light, but that is the desired effect. All right, so making progress. We've got 3 tacks at each corner. The angles have come out pretty good. I'm really happy with these. It's pretty square and true. And this was the objective, was this pocket. So if you could shoot this corner, right? So we have this pocket here. We have the remaining corner pieces. They will fit in like so. And that will give us the 3D miter cut corner that we want. Something like that. And then this will be the, so we're gonna finish welding this, and that'll give us some structure. We'll weld in these 4 legs, and then we should be well on our way to having the table. Thanks. Really happy with the joints here. I've got it held here in place with magnets. Got my safety shoes on in case it falls off, so the sharp corner doesn't spear the top of my foot. And yeah, I've been trying to get these legs tacked on, and then the braces, and then we should be in good shape. That's that. It's tacked in now, so time to finish weld. Clean up that tungsten. Hey, so wanted to show my fit up. TIG welding is largely about preparation. I guess a lot of things in life are, but these are my seams pre-weld, all right? So look This fit up is pretty good. My hope is to not actually need any filler rod here. I try to just a gut rod, and it's clean and I'm ready to use it, but my hope is that I can just run this along. Anyway, it's going well. Everything is essentially together, and I am finishing up my welding. So typically at this point I get excited and start rushing and skipping steps, which is bad and wastes all the time I spent patiently preparing. So I'm gonna not do that. I'm gonna try to show you. This is what we've got so far. Round and third and heading home. I know it's noisy, the machine's on. I'm actually not willing to turn it off right now. I'm making good progress. But I made these caps for my end pieces and welding them into place. Pretty much not needing any rod for this, so that's good. And I'm almost done. The structure is complete, so I just need to put these end caps on and places to screw the top to the frame, and then decide what I'm going to do for a finish. All right, here it is. Ready for final assembly. Welded, ground, painted, dried, tabs installed. All I gotta do now is lay the top on it, screw the top down, and start using it. Do some cable management, and we'll see. But I think this is gonna work out pretty well. So here is my new desk. My chair fits under it without hitting. Should be exactly the right height for me to type. And yeah, strong as hell, 2-inch steel, a piece of discarded butcher block. I looked around online, this is worth maybe $600 piece of wood, so I'm pretty stoked about it. But yeah, this is the new job. Working location. So that's it. Hopefully some of the video was entertaining or educational, and there we go. This is the result.